Thank you very much for your time today. And I'm very fortunate to be here to spend some time with you to talk to you about what IoT foundations are in terms of what some of our customers are doing using our technology. So what I don't want to focus today's presentation on is what is IoT. I think most of you probably have a pretty good understanding around what that is. Might have already seen some use cases around different companies' offerings. So what I want to focus on today is more on the foundation of creating IoT applications, interfacing with the user. Because all of us need to interact with IoT, unless otherwise it just becomes a bunch of data and it doesn't really exactly do all that much. So why are we talking about a foundation? We talk about a foundation because obviously a lot of people think about IoT, they think that there's a lot of data, a lot of volume, which obviously that is very true. And I don't want to spend too much time talking about the data aspect of it because you all know that already. But what I want to do is really focusing more on the two other aspects in terms of scaling the capability to do analytics, scaling the capability to process all of that data in real time. And then more importantly, how do you take the analytics and the insight and build it into the applications that might be servicing within your mobile phone or other devices that your users can interact with. So it's really a full circle around what IoT is promising to be. In fact, if you look at the common patterns around IoT today, it usually comprises of three different areas. So the first obviously is the data aspect, right? So there's a lot of it. A lot of it might be coming from sensors, might be coming from a watch, might be coming from a mobile device. So there's obviously the data aspect of it. You need to manage it. You need to store it. At the same time, now that you have all that data, you need to analyze that information. So that makes sense as well. But once you analyze it, you need the third aspect of this pattern, which is the apps, right? You and your customers typically don't interact with the data directly. They interact with the apps. So in order for IoT to really make sense, all three of these aspects need to be put in place. Now, let's take a look at some of the top verticals, industries that are predominantly focusing around IoT. So obviously the first one that you see on the slide here talks about the industrial manufacturing, right? So the GEs, the Philips of the world. They make very big equipment. The equipment is generating a lot of data, and they're predominantly focusing around how they can optimize the efficiencies around that data, optimize the efficiencies around the processing of that data that are being generated from the equipment. You also see up here auto manufacturers, right? Auto manufacturers, cars. So you see the likes of BMW and Mercedes and Tesla, right? And Chrysler and Fiat and Ford that are all focusing around creating this notion of a connected car. And I will talk a little bit more around the connected car later on in my presentation today. Then, of course, you see the consumers, right? And we see a lot of devices that a lot of companies are creating here in Japan, in Korea, in China, in the US. They're creating a lot of devices that people can wear all over them. The objective is to be able to really measure and capture the human behavior, things that we're doing with us, things that we're doing in our homes, right? So extending that into the connected home concept as well. And then you see media, right? This is predominantly around audio, media, video, all of the things that we are predominantly consuming now on devices like these, where we are interacting with that data, and it's generating more data back into the system for analysis. So they can know more people like me, what am I looking at, how do I learn to look at it? So there's the media aspect of it as well. And then the last one that you see on the list here, it's around the urban infrastructure, or some people like to call it smart cities, right? And this is the notion where they're taking information from the transportation department, information from the health department, information from the immigration department, and bringing all of that information in order to make the operational aspect of running a city, or in some cases, running a country, much more efficient. Connected countries, connected nations, smart cities are all areas that are being covered in that industry. So these are the top verticals that we see around the world where they are really focusing around those three aspects within the IoT patterns that I talked about. In fact, if you look at the industrial manufacturer for a second, you'll probably recognize a lot of the logos down on the bottom left-hand side. These are companies like Tyco, Philips, GE, Bosch, Siemens, and so on. Big, heavy manufacturing companies in the world. What they are predominantly focusing on now, beyond what they have traditionally been doing for a long time, is moving up onto the top right-hand side. Essentially, what you can think about is they're moving from their traditional hardware-centric business, and they're now moving into a heavily software-centric business. Smart services, smart systems. They're trying to gain more insight out of the hardware that they have manufactured and sold to the customers, because they see that as their new revenue stream and a newer way that these companies can interact with their customers. You also see that in the auto manufacturing space, as I mentioned before. Now, the interesting thing is the clips, the newspaper clips that you see on the slide here, you don't see too many auto manufacturers, right? Instead, you see companies like Tesla, you see companies like Uber and Google and Apple. So what this is really telling us is there is now a blurring between the software industry and also the auto manufacturing industry as well. Because who's to say what a car will be looking like in 2 years, 3 years, and 5 years, right? There's a lot of operational aspect of it that can really be automated. There's a lot of experience can now be extended into the car. And like I said, I'll mention more about this later on some of the projects that we're doing with these companies. But the auto manufacturing industry is putting heavy focus into IoT, heavy focus. And you'll be surprised at some of the things that they're now doing, which really changes our perception of how we interact with a vehicle. Now, when we talk about the foundation of anything, the foundation typically starts at the plumbing level, right? So you talk about the foundation of this hotel, this building. You think about the pipes, you think about the electrical outlets, you think about all the things that we typically don't see. It's all hidden away from us, but that's the foundation. So when people talk about the foundation of IoT, sometimes they focused on the plumbing aspect, the monitoring aspect, and so on. But in reality, if you think about you as a user, right? You as a user or your customer as users, they don't really see the plumbing. What they really focus on is the engagement aspect. How do they engage with this IoT application? How do they work with the data that you're presenting to them? How are they generating more data so you can go analyze it? And you, as enterprises and system integrators and service providers, how do you build a platform so that you can bring all of that together? So when Pivotal talks about IoT foundation, that is what we're talking about. Now, that doesn't mean the plumbing is not available. What that really means is the plumbing is already there for you to use. You don't have to spend time looking at it. You should be spending more time looking at generating value for your customers instead of looking at the plumbing. So our foundation is really focusing around these various different aspects. And in fact, if I draw that out in a diagram, if I draw it out in an architectural diagram, high-level diagram, it will look something like this. On your left-hand side, that's the edge, right? By edge, what that means is this is an edge, right? The devices, the sensors, the things that I'm wearing, the things that's in the car, that's the edge, okay? Now, the edge is generating data that needs to be ingested. It needs to be streamed in real time and perform analytics on the fly. All of that data needs to be stored somewhere and managed somewhere. All of that data needs to then be able to look at a long-term trend and be able to identify if there are any patterns that you can gain some insight out of it. And then you need to look at building IoT applications so that you can take those insights and bring it back into the edge so the user can make use of it. So think about it as more of a circle. It's a cycle. You start at the edge, you process that data, you pump it into the application, you send it back into the edge. That's essentially what IoT is about. So don't think about IoT as bringing all of that data in and storing it somewhere. That doesn't do anything. It has to go in a circle. So what I want to do over the next maybe 15 minutes or so is walk through with you each one of these components and how our customers are actually using these components in order to satisfy some of the IoT requirements that they may have. So let's start with these three orange areas first. So the first one on top, that's reaction, right? How do you react to the data? The one in the bottom is ingestion. So these things, right, these devices are generating a lot of data at very, very high speed. How do you bring it in? How do you stream it? And then how do you do analytics on the fly, real-time analytics? So those are the three components I'm going to talk about first. The first one, the first technology within our portfolio is a technology called RabbitMQ. It is a high-performance messaging broker, right? So think about it as a vehicle, a bridge, a path that messages are flying around. Now, when we talk about high performance, take a look at what the headline says. RabbitMQ hits 1 million messages per second on Google's compute engine. Now, this is not a statistics that Pivotal as a company we did. This is a statistics that Google did for us on this technology because they use this as well. Just to give you some context around how fast 1 million messages per second means, if you take 1 million per second over the duration of a day, that equates to roughly 86 billion messages one day. Now, in 2012, in the United States, as you can see over here, to roughly 6 billion text messages on any given day. So this capability has the capability of generating 86 billion messages on a daily basis. This is a high-performance messaging broker. Now, why is this important? When you have IoT devices and when you have these mobile and connectivities that are all over the world, and you've got users using it at all hours of the day, you have no idea how to predict how much high or how low these workloads are coming through, how many messages are coming through. So you need a high-performance messaging architecture just to capture that information. We haven't even done anything else, but you need to capture that information as fast as you can. And that's why this technology is made available in order to do that. And by the way, this technology is open source. In fact, every single technology I'm talking to you about today is either an open source technology that Pivotal has adopted, or it is one of our technology that we have now shared in the open source community. So you will hear open source as a main theme for our IoT architecture and our portfolio of products over the next few minutes. So that's RabbitMQ. Now that's streaming the data in. The next thing is, once you've collected the data, what can you do with it in real time? You're going to have data coming from various different sources. Some of them are going to come from back-end systems. Some of them are going to come from databases. Some of them are going to come from a weblog somewhere. So the idea about Spring XD is the ability for you to connect into these data sources almost with no programming whatsoever. You literally just call the connector, connect into it, and start streaming the data in. So that's the first step. The second step is, while you stream that data in, you can literally process that data in real time. You can process it in real time, no matter where it comes from. So that's the second aspect of it. The third aspect, which is on over here, is this notion that you stream it in, you started the process, you might want to do some analytics on the fly as well. Think about retail examples. Think about you walking into a department store and you are on your phone and you're browsing the catalog. The store knows you're right there. So they need to be able to analyze the data in real time and be able to say, hey, here's a promotion that is going to be suitable for me while I'm actually in the store. That's why all three of these components becomes very important if the operation that you're running tend to be more on a real-time basis. So that's what Spring XD does. If we continue to move on, let's take a look at the analytics aspect of it. So this is now looking at very large chunk of data and then trying to see patterns and build models around them. Okay? So that technology is called Hawk, H-A-W-Q, along with a number of open source based libraries that you're able to leverage as well. So essentially what Hawk is it's an analytic engine that sits on top of Hadoop. Now, when people talk about IoT and when they talk about Hadoop, very often they basically put those two things or those few things all together as the same kind of theme that they're talking about. But the reality is Hadoop is still a maturing technology. Hadoop still are looking for many practical use cases of what that is meant to be. And if you look at the chart on the right-hand side, this is a survey that talks about the number one choice for data science. You'll see that Hadoop is not number one, right? The people that actually know how to analyze and manage data, they are all saying that SQL, at the end of the day, is still going to be the main tool that they are going to be using to analyze data. So what this technology is meant to do is you can store the data in Hadoop, but you can access it in SQL. You don't have to know the programming languages of Hadoop. You can just use SQL, which most analysts know how to do already today. And that's what this capability is really meant to be. You can access and store data through SQL directly into a Hadoop distributed environment at extreme high speed. That's what that technology is meant to do. So you can start to see the formation of these components. We talk about collecting the data. We talk about streaming and analyzing that data in real time. Now we're talking about accessing that data in a distributed environment. So now you can start to build some models around the patterns that you're seeing within the IoT data that you've collected. Then, of course, we have to talk about storage, right? One of the key themes about IoT, obviously, is the volume aspect of it. So from a storage perspective, Pivotal offers three different ways of storing that data, right? All integrated together, but three different ways. And the reason for that is you have various different workloads that you might be storing in. Some of it might be predominantly transactional, numeric data. Some of it might be files. Some of it might be various different aspects of it. So we give you a choice in terms of how you're going to interact with that storage layer of the data management. So let me talk about the first one, which is Greenplum. So Greenplum is a technology that's been in the market for quite some time. It's widely used across the world, in the United States, in China, in Korea, and right here in Japan as well. It is a massively parallel query engine. Massively parallel query engine. And the goal of it is to provide an environment where you can perform analytics at extreme high speed, right? You can store that information, process that information all in parallel, providing you the capability to look at a massive set of data and be able to run simulations and run models at very, very high speed. At the same time, it's also been certified with many business intelligence tools that a lot of your users may be using today. Tools like Tableau, tools like Business Objects and SAS and so on. So you can put these tools directly on top of Greenplum and be able to access that data almost the same way as how you would access any other data infrastructure today. So that's Greenplum, right? That's mostly focusing around a transactional aspect of the IoT data that you might be collecting. Then the next technology is called Gemfire. Now, this is also a technology that's been in the market for quite some time. It is predominantly geared towards an in-memory based real-time data distribution grid. What does that mean? This technology is predominantly focusing around doing small things at extreme high speed across a very wide area of network. Right? Think about it that way. In the investment banking industry, right, have been using this technology for a very long time to process trades and calculate risk models on the fly. And if you think about the operational in the banking industry, and now in this scenario, we're talking about IoT, it's very similar. There's a lot of small bits of data that's coming through in real time, and you need to be able to store it, analyze it, and be able to make it available. And that technology is Gemfire over here. It is also open source. This is a technology that we have created, and now we have shared with the open source community, and we're inviting more developers to develop on this technology so we can all innovate together to make this capability even stronger than where it has been. And it's interesting also on the chart that you see on the right-hand side that in terms of new technologies, analytics technologies, you actually see in-memory systems even higher than Hadoop as well. So again, don't take IoT and big data and automatically put an equal sign beside Hadoop, right? That is not a really correct concept to think about. There are various different types of data workloads, and you should be looking at these workloads very specifically to optimize for the operations that you're trying to do. The third aspect of the storage obviously is Hadoop, right? So there is a Hadoop component within our IoT platform. Our Hadoop distribution is called Pivotal Hadoop. Now, the interesting thing about Pivotal Hadoop is that it is not a proprietary-based Hadoop system. This is a commercially available Hadoop distribution that's based on an open source consortium called Open Data Platform. In fact, this Open Data Platform was formed from Pivotal and many other partners that you see on the slide here as a consortium. So we want to create this platform, this Hadoop distribution, where it is transferable from one technology stack to another. It prevents locking you in a proprietary stack where you don't have the capability to leverage different parts of the technology and from different vendors to serve your specific need. So when we formed this consortium together, we made it very specific that within all of these vendors' technology, the applications will run on top of them seamlessly across the board as long as we are all using the same core within the open source foundation. Okay, so that's one very important aspect to know about here. So there's Hortonworks, there's IBM, there's VMware and EMC, and other companies that you see on this slide as well. Now, we talked about streaming the data, analyzing the data, storing the data. Now we're talking about the actual, how to put it all together, right? The user needs to be able to interact with it. So the three orange boxes that you see here are more around user engagement. It's around the IoT applications. In many cases, these are mobile applications. How do they interact with the data portfolio? How do they then interact with the sensors and the devices that are at the edge so that the user can see the results almost immediately? So now we talk about this platform called Pivotal Cloud Foundry, where we bring all of these components together. So what is Cloud Foundry? Think about Cloud Foundry again as a cloud-native platform, application platform. So what does that mean? If you think about your traditional stack, right, your IoT applications, and then you have your middleware stack, your databases, your messaging bus, and then you have your infrastructure, right? So that's a very traditional way of building applications. In the world of cloud and infrastructure as a service, right, that you have probably heard of from the EMC sessions and the VMware sessions during the day, You bring all of those physical resources and you create something called infrastructure as a service, right? Like a cloud infrastructure platform. But the middleware layer still are fairly independent, and they are still very much siloed, right? A lot of them are living in different VMs and living in different resource pools. And it makes creating these applications not as seamless and not as easy as possible. So what a lot of our customers are looking to do is they're saying, look, when I'm building an IoT application, I don't really want to think about the plumbing anymore. I want to focus on creating value. I want to focus on creating the apps, connecting to the data, doing the analytics, and surfacing back to the user. They want to focus on the top bit. So what they've been asking for is, hey, do the same thing that you have done on the physical layer. Can you do it in the middle as well? So I don't have to worry about the plumbing in both of those layers. I'm just focusing on building the app. Right? That's what Cloud Foundry is really meant to do. It abstracts a lot of the plumbing aspects, the operational aspects, the monitoring aspects of building applications. It abstracts that out of the developers. They don't have to think about it anymore. They create a piece of code, they deploy it, and they run it. In fact, in more detail, it looks more like this. Let me build it out. So as you can see, right? Code, program, deploy, and run. So this platform is really meant to be for the developer to say, I'm just going to build something. It has various different capabilities. Once I build it, I'm going to push it, and then I'm going to run it. That's it. I don't have to worry about which server it runs on, which database it's going to connect into, which storage device is going to be storing the information. It doesn't need to know any of that. It makes developing software that much faster, that much more efficient, and more importantly, building IoT applications and IoT product give you a much better time to market aspect than ever before. So from a platform perspective, what we're trying to do, if you think about piecing all of these things together, is you've got your edge, right? On the left-hand side, your car, your connected car, your mobile devices and whatnot. You have your streaming aspect on the very top, right? RabbitMQ, you can see it up there. It streams the data, it processes the data, it creates the analytics right in with Gemfire and Pivotal Hawk and other technologies in here. The application sits on Pivotal Cloud Foundry. It services that information back into the apps, and then it brings it and scale it according to user demand back into the user, back into the devices. Right? It is a round trip, as what I mentioned before in the first few slides. This is the Pivotal IoT platform that most of our customers are using. Some are using the entire portfolio of technology. Some are using some aspect of it, tending onto the front end or the back end. And in the next few slides, I want to share with you some customers that are using this capability, so you'll have some more practical use cases instead of just the technology that's sitting behind the scene. So what are some customers that we have in this space? Remember I talked about the top verticals on the very first slide, right? So industrial companies, auto manufacturers, retailers, and so on. So let me share with you some of those. This is GE. This is one of the division within General Electric, GE Wind and Power. And so this one is quite interesting. So when GE builds these wind turbines, the ones that you see in the picture, very often these wind turbines are generating a lot of data around how it's operating, how the blades are running, what energy are they producing, are there any external factors that are affecting it, weather, and so on. All of that data is being collected now and streamed right into a Pivotal-made architecture on the right-hand side over here with the technology that you saw previously. In fact, if you look at right in the middle, it says that every second, there are roughly about 100,000 data points that are coming from these wind turbines that are being fed and collected and analyzed, about 100,000. Now, if you recall, when I talk about RabbitMQ, and I talk about the Google benchmark that they did with us, our technology is it's capable of handling up to 1 million messages a second. So this is only about 10% of what we're actually capable of doing. But 100,000 data points streaming in real time into the architecture so they can analyze and do reporting and understand the operational aspect of how these equipment are actually behaving right at the customer site. So this is an industrial use case that you can probably see every time you look at one of those windmills now. The next one is a little bit different. So this is in the retail and fabric industry. This company is called Under Armour. They are very famous in the fitness, the health, the sportswear category, right? Under Armour. In fact, there's a number of YouTube videos online that talks about this particular project that they did with us on. And if you think about what they're doing here, what this company is aiming to do is not just become the #1 sportswear company in the world. That to them is a small goal. What they want to be is the #1 connected fitness platform online. That's a very big goal. And they started on that goal with building a number of IoT-based applications on the mobile devices to help their users track when they're doing fitness exercise, when they are interacting with the clothing that they're buying from Under Armour. How are they using it? What's the behavior? How much sweat are they generating from running or from whatever it is? They want to collect all of that information, not just for the user, but also for the company to design better products for the different type of activities that their users are wearing their garment for. Right? So this is a very dramatic way of not just creating a consumer app. The consumer app is not the hard part. The hard part is bringing the consumer-based information, the information that they're collecting from the fabric, bringing all of that in, doing the analysis so that they can design a product even better and more personalized for their user. This is a very different way of thinking, especially in a very traditional garment, fabric-centric industry like the one that Under Armour is in. In fact, the apps that I have up here, you can download that on the Apple Store. You can go to the Google Play Store and download that as well. These apps are very, very popular online. These applications were co-developed with Under Armour and Pivotal engineers together. So we, at this project, we're very much helping them focusing on the front-end aspect of the IoT foundation as they continue to build more technologies and collect more data from the products that they're going to market today. So that's Under Armour. I encourage you to go to the Apple Store or the Google Play Store and take a look. So next is auto manufacturers, so cars, right? This is Mercedes, as you can see. The pictures on the right here, it actually came from the Connect the Car conference that was hosted last month in Europe. And Mercedes was one of several car manufacturers to talk about their connected car concept. This is a project that they also did with Pivotal in Europe. So essentially what they're doing here is a lot of auto manufacturers now are trying to extend the car as part of your mobile life. So let me explain what that means. So typically we think about a phone as a phone, and we think about a car as a car. And yes, you can take your phone and you can plug it into the car and you can listen to music. And we've been doing that for quite some time. But what they're doing now is they're extending the experience of the phone into the car, from the car back into the phone. Let me give you an example. When you go into a car, and let's assume the car has a navigation system, right? Most navigation systems either ask you to punch in things, right? So I used to drive a Lexus before, and I remember it was basically a touch screen that I had in the middle of the car. And you punch it, and then it shows you the routing. And then I had an Audi, a German car. And the German car basically is mostly a wheel, right? So you turn the wheel, you press, you turn the wheel, you press. It is a horrible interface. It is not easy to use, right? Now, if you think about entering an address on your phone, It is very easy. You go to Google Map, you punch in, it gives you the map right there. So part of the feature in this app is actually extending that. So if you know where you need to go, punch it onto your phone. As soon as you get to your car, it gets automatically synced into your car. You don't have to do it in the car anymore. That's what I meant by extending the experience from the mobile device into the car. But at the same time, it can also be from the car back into the phone. So you essentially never left the car, right? The car and the mobile device is now merged together on the same platform. That's what a connected car is really meant to be. How the car is interacting, your personal settings in the car, you can store it on your mobile device. As soon as you go in, it's automatically all configured. That's what it's really meant to be. And Mercedes is one of the more forward-thinking company that have been working with us on creating this experience. It is really about creating an experience from the phone in the car, from the car back into the phone. All right? So don't think about connected car as all sensors from the wheels. It is that, but it is also the experience as well. Because if the experience is not fantastic, people are not going to buy your car. Doesn't matter how great your engines are. The experience is now going to be the key in terms of how buyers are deciding what they're going to choose. Well, here's another example. So this is also an auto manufacturer. This is not a Japanese one. This is not a German one. This is a Chinese company, right? They are the largest auto manufacturer in China. They're also the 8th largest in the world by the number of cars that they produce. This is Shanghai Auto or Shanghai Motor. Now, instead of focusing on the front end, which is what Mercedes focused on, these guys focused on the back end, right? These guys wanted to create a platform that they're calling the Internet of Vehicles. Essentially, what they want to do is they want to understand all of the vehicles that they have out into the market, right? The ones that are equipped with this capability. How are the cars interacting? How are they reacting? How are the parts functioning? When do the parts need to be replaced? Are there anything that needs to be pushed to all of the cars because of a new patch or new whatever it is, right? Their goal is to create an internet controlling all of the aspects of how they need to operate within the car, within the vehicle, making life easier for the user. Almost exactly the same way as you having your Apple device or your Microsoft device or your Google device. When they have a new update, you press the button, everybody updates it. The same way for cars, right? You can almost think about a car now as a computer running on 4 wheels. It's just a computer. They're all connected online anyways, either through your phone or directly through the car. So just a computer running on 4 wheels. If it's an electric car, it's a computer running on 4 wheels with a bunch of batteries, right? So you can almost see the difference now in terms of where we see the auto manufacturing industry before and where they're going. And if you look at this slide here, this is a graphics that I downloaded online, and you can see this is 2020, right? What does the car look like in 2020? Now, 2020 it seems like it's very far away, but I was looking at my calendar, it's only 5 years away or 4.5 years away. It's not that far away. So what would a car look like in 2020, right? The car may very well look like this. There's still going to be companies that are focusing around the drivetrain, right? The physical aspect of the car, and it's increasingly being taken over by companies like Tesla, right? Where they're creating a lot of innovation around the driving mechanism within the car. And then there are companies like Apple that are literally taking over the user experience of the car, right? You look at things like CarPlay, and Google have a similar technology as well. They are now controlling the user experience. That experience that I told you about, that's what Apple is working on. And then, of course, Google had been spending a lot of time working on the autonomous car, self-driving car, right? People don't need to drive anymore. And think about the experience. You put in the address, and then something like an Uber calls a car over. You walk into the car, there's no driver. it just drives itself to the destination that you want it to be. The only thing that you interact with is on the phone and physically sitting on a seat in an autonomous car. Right? That's where the world is going. That's the world that the auto manufacturing industry is looking at. So when they think about connected car and they think about IoT, it is not just collecting data and doing some analysis. It is front to back, back to front. Right? That's what we're seeing, and these are the projects that we're working with some of the most popular car manufacturers out there in the world. This diagram probably looks very similar by now. Right? This is our connected car architecture. This is what a lot of our customers are using. This is just a high-level description around how we connect into the car, how we bring the information, how do we analyze that, what are some of the algorithms that we're running, what are some of the dashboard that customers are creating, and so on and so forth. So that probably looks very familiar to you. So with that, I'd like to wrap up my presentation for today. I know we spent some time talking about the foundation of IoT, and I went into some details around the different aspects of that foundation, all the way from data collection to data analytics, to real-time processing, to storing of that data, to creating the application that leverages that information, and then sending it back to wherever the user happens to be. So when we look at IoT, we're really looking at a different way of building these applications, a different way of analyzing and managing that data, and a different way of looking at the application as it interacts and engages with the user. And when we think about IoT, these are the aspects that we think about. So with that, I'd like to thank you very much for your time and hope you have a very good rest of the day. Thank you.